Okay, before we start 6.3, let's just review. We've already discussed that in order for two triangles to be similar, okay, we have the first rule, that is asimilarity. What is asimilarity? Angle. So if this is 30 degree and this 50 degree, 30, 50, doesn't matter. I can just rotate the triangle, right? Rotate the triangle like this. The 30 will go up, 50 will go this side. It will become same only. So the angles are same, right? If the angles are same, asimilarity. Done. Okay, that is one way. The second way is SAS. SAS similarity. Okay, before we do that, let's do SSS. Similarity. Okay, for SSS similarity, we have to show that not the sides are same. Okay, don't get confused. In concurrency, SSS means all the sides should be same, but in here it's not like that. We just have to show that the ratios are same. So suppose it is 2, 3, 5, then this should be 4, this should be 6, this should be 10. It can also be what? 6, 9, 15. It doesn't matter. Why? Because see, if you divide this and this, wait, these two is similar and these two is similar. Okay, so if you divide this and this, you get 4 by 2, 6 by 2, 6 by 3, and then 10 by 5. So if you cut 2, 2, 2, right? And if you do this, I'm gonna see, you have to arrange the triangle. What you can do is you can rotate the triangles and try to arrange, but you cannot just flip like this, squishy there. You just have to you can rotate the triangles, okay, as much as you want. So if I bring the 6 this side, the 9 will go up, the 15 will go down, right? Rotating this way. So I'm comparing these two sides. So 6 by 2, this by this. Next I'm gonna go right. So 9 by 3, and next this 15 by 5. Got it or not? So I just rotated this here. So if I rotate this triangle this like this, 6 will go this side, 9 was here, so it will go up, 15 was here, so it will go here. So 6 by 2, 9 by 3, 15 by 5. So 2 3s are, 3 3s are, 5 3s are. So we're getting the same ratio. So this 2 is also similar. Got it or not? So if these two is similar, these two should also be similar. So if we do it, the smaller side is 4, here's 6. So 6 by 4. Next, I'm bringing this, it's becoming like this now, I'm rotating this like this. So 6 by 9. Wait, I wrote the bigger side here, so 9 by 6 over like 9 by 6 and 15 by 10. So 2 3s are, 2 2s are, 3 3s are, 3 2s are, 5 3s are, 5 2s are. So 3 by 2, 3 by 2, 3 by 2. The ratios are same. So this 2 is also similar. So we have that AA similarity, SSS similarity. And then lastly, we have SAS similarity. Now you know what is SS and AA. So SAS means in a triangle, not two sides are same, but the ratios are same. Okay. So if it is 3 and 5, this should be 6 and 10 and 45, 45. So if we divide these two, 6 by 3, 2, 10 by 5, 2, and the angle between them is 45 degree. Angle between them, okay? So if the 45 degree is not here but here, then it is not similar, okay? We cannot say those are similar because the angle is in a different location. It will be between them. So now let's over 6.3. Let's start. In this case, we'll just try to rotate the triangles, okay? So if I rotate this triangle this way, or maybe rotate this triangle this way, doesn't matter. See, I'm bringing P this side, okay, so that the longer side and the longer side should be copied. So P is, I'm dragging the B this side, so Q was here, so Q will go up, R was here, so R will go. So 이것도 inaccuracy. 이렇게 해야 돼. Got it? So PQ is 6. This 4 was down, it'll go up. This 5 was here, it'll go down. Huh? Now if you compare these two, AB, let's divide AB by, or we can do Q. तंग वाला ऊपर लिखा है, easy वाला है, तो नहीं मैं तंग वाला ऊपर लिखे थे. QR by AB, but it doesn't matter actually. QR is 4 by AB is 2, so we're getting 2, right? And then we can do QP by AC, 6 by 3, we're getting 2. And then at last we will do PR by BC, 5 by 2.5. If you cut, you'll get 2, because 2.5 double is 5 only. So in all three cases it's 2, right? Therefore, since QR by AB equal to QP by AC equal to P by BC, triangle ABC is similar to, see, this is where a lot of people make mistake. ABC, it's not similar to PQR, okay? It's similar to QRP. ABC, one rotate probably keep Aishina, it is up to the Q. ABC and QPR are similar, okay? I'm doing this number 2, okay? Number 1, do it yourself. I'll do only 3 questions from question number 1. The rest is for you to try it yourself. So let's rotate according to what we need. So we can rotate this, I guess. So F, I rotate it in such a way that the F goes up. So F is 80 degrees because I want the angles to be matching. Nah? So if F goes up, this is going up, then this goes down, then this goes this side, right? So D goes down and E goes to the side. So we have EF, this E, okay? EF is 6, and then FD is 5. So just from looks alone, by looking at these two, we can say it's not similar because this tree is not here. If suppose the tree was here, then it would have been similar, but the tree is not here, it's down here, right? So we can say just write AB by FD is not equal to AC by FE, or we don't know, not enough information is there, right? Therefore triangle ABC is not similar to triangle DEF. This is asking us to say which ones are similar, so you don't have to write everything in details, okay? These two, let's see. Okay, for this question we have to use a little extra thinking. Why? Because if this is 80 and this is 70, in triangle, suppose in this triangle, angle D plus angle E plus angle F will be equal to what? 180, right? Angle sum property, right? So okay, let's in triangle DEF, angle D plus angle E plus angle F equal to 180 degree. Angle D is 70, E is 80, angle F equal to 180. So angle F equal to 180 minus e to the plus 150 bola. Angle F equal to 30 degree. So we can keep 30 degree here. So if this is 30 degree, this is 80. Nah? So in triangle DEF and triangle PQR, angle E is equal to angle Q, and then angle P is equal to, angle F is equal to angle R. Therefore triangle DEF is similar to triangle PQR. That's by A similarity. We don't have to write everything in details, we just have to say which one is similar and not. But anyway, that's how you do it, okay? So let's do question number 2. If in case you have doubt in question number 1, do let me know, I'll help you out. So if triangle ODC is similar to OBA. So they have given us that. So whenever this kind of question is there, it's good to draw the given triangles according to what they have given us. So ODC, OBCD D OBCD so OBA. Because similar triangles means this thing we should be equal, na? So, and it has to do with angles, all the angles. So we know this and this will be same, angle O and angle O. Angle D and angle DB will be same since they are similar, because they've already given us that these are similar. So these angles will be same, right? C and A will be same. So from here they have given us D as 70. So angle B 70 to by this here. Now they have given an extra angle BOC, which is not here at all, right? So we can use that to find the rest of the angles. Okay, so let's do this first. This is a straight line. See, let's take it this side. So this is 125 C, or I'm just drawing the half of it. Okay, DB. So this DB is a straight line, right? DB is a straight line, and this one angle. So this angle, if you want to find out, this plus this will always be 180 degree, right? Because it's a straight line. So let's start with that. Okay, DOB is a straight line. Therefore, angle COB plus angle COD should be equal to 180 degree. But angles COB or BOC is given 125, right? So instead, I'm going to write 125 plus angle COD equal to 180. COD equal to 180 minus 125. So if you subtract 180 minus 125, you'll get 5. So 7 minus 2 is 555, right? So we got this one as 55. So which means DOC is 55. So if this is 55, this will also become 55, right? Or we can even say vertically opposite angle, so doesn't matter. But we have to use, since we're studying about similar triangles, let's just use similar triangles. Okay, so therefore angle COD equal to angle BOA, na? AOB, angle AOB, BOA, AOB same, equal to 55 degrees. Reason, triangle ODC is similar to triangle OBA. Even if you use vertically opposite angle, it's not wrong. Okay, I'm just using similar triangles formula because we're doing similar triangles chapter. Now we know this is 70, so we need this, an extra angle, na? So for that we can use angle sum property. So in triangle ODC, angle D plus angle O plus angle C equal to 180 degree, angle sum property. Okay, so D is 70, O we just got 55, C we don't know. So angle C equal to 180 minus 70 plus 55 will be 125, nah? So we're getting the same thing only, 55, right? So even this is 55. Therefore 100, 110, 180, yeah, angle OCD equal to angle OAB equal to 55 degrees. I wrote here this, okay? See, starting the OO like this, na? COD, COD, AOB, 55 pi c. Here we got angle C, so this is 55. So we're getting OCD as 55. So this angle should be equal to this angle, right? So OAB is also 55. Same reason as above triangle ODC is similar to triangle OBA. And in this particular question, I've seen some students make mistakes by writing what alternate angles, this and this, but nowhere in the question is it given that these two are parallel lines, so you cannot use alternate angles, okay? But you can use vertically opposite angles. It doesn't matter that though. Now, so what else do we need? The OC, they asked us to find. So the OC we already got. The OC, COD, same thing, yeah? DOC, COD, same thing. DCO and OCD, same thing. So we got it, right? And then OAB also we got it. So that's that. Okay, let's do number 3. Diagonals AC and BD of a trapezium ABCD with AB parallel to CD. So these two is parallel, which is given in the question. Intersect each other at point O. Using a similarity criteria for two triangles, show that this equal to this. So it's the exact question as what we did in 6.2, but then this time we cannot draw. We are not required to use Taylor's theorem, but instead we are asked to use similar triangles property. So first of all, they have not said which two triangles are similar. They're just saying show that two triangles are similar, and from that prove this. So let's see what which sides are these. OA is here, OC is here, OB is here, OD is here. So it's obvious, right? This triangle and this triangle, this. So it will be the triangle, okay? Similar as a decoder triangle, okay? So in the previous time, alternate angles. Now we can use alternate angles. Alternate angles, in case you guys have forgotten about it, this is what alternate angles are, okay? In case these two is parallel to each other, then any line drawn, any line, it can be like this, it can be like this, doesn't matter, right? Any line drawn, the intersecting these two, the two parallel lines, then this angle and this angle will always be equal. It comes in kind of a Z shape, okay? So this angle and this angle is always equal, and then this angle and this angle is always equal. It's called alternative angles, okay? Which you have learned in class 9. So in this case, if this is the line, this and this will be equal, this and this will be equal, right? The ulta itu fale dekhi utu fale ho jaye equal tag na. So usually it comes in a Z kind of a shape, this like this, okay? So in this case, these two triangles in triangle AOB and triangle COD, okay, we can say that angle OAB, which is this OAB, equal to angle OCD, this. See, I just drew it here, right? These two lines are parallel to each other, and then we have a line which is AC intersecting these two lines. So Z shape, na? This angle and this angle should always be same. So it's the same thing I just drew it, A, B, C, D. So like this. That's why equal angle, same. So that is alternate angle, right? You have to write the reasons, okay? Next is, we can say this and this is also equal. Same thing, alternate angles again. We don't even have to think that much. Parallel lines, so it's literally same, exactly the same. This one and this one, just like how we drew here. This one and this one. So this one and this one is same alternate angles. So angle OBA equal to angle ODC, same alternate angles. And we don't even have to show the third angle. I know that These two is already equal, okay, vertically opposite angles, but we don't even have to show that because A is similar to is enough. Two angles is enough. I have to show you. So therefore, triangle AOB is similar to triangle COD by AA similarity. So these two is similar. So whenever you've already proven similar, what you can do is in the rough section, you're going to draw the two similar triangles in according to their similarity. Okay. Yeah, this will be pushing mistake way, and this is a actually very good trick to do it. So first draw the two triangles in how they are similar to each other. So angle O and angle O is same. So I'm writing O and O. Okay. You have to listen very carefully because we'll be doing these kind of things a lot in the future. So A and C is equal. So if I write A here, C should be written here because A and C is equal. And then B is equal to D. Got it? We just proved that angle A is equal to angle C. So A and C should be on the same side. B and D we proved is equal. So B and D should be on the same side. This corner, right corner. And O and O is equal. So O and O should be the vertical opposite angles, right? So once you have done that, all you have to do is put the ratios. So look at what we need. OA. So OA is here. So I'm gonna take this one by OC. OC is right here, and then OB. We need OB. So we need this side and this side. So therefore, OA, this side divided by this side, according to the ratio, equal to OB by this. You can even write equal to AB by CD also. Doesn't matter, but we are asked this. We don't have to do extra. But even if you write AB by CD also, it's right on. Done. Okay.